This should be visible. This is from your Kenneth Rosen book only. If this is visible, observe that we are using a notation P arrow Q. This P arrow Q stands for P conditional Q. How to write this P conditional Q? We are writing if P means some condition, then Q. This basic form we have seen, okay, during our earlier lectures. Now you must be curious to know what are the various variants by which I can represent this P conditional Q. You could observe here if P comma then Q. This is the first notation. The other notation is if P then keyword is not present, comma Q. This is also allowed in the case of condition. You could also write P implies Q, implies for this directional arrow. P only if Q. This is also allowed. The statement could be written in the reverse manner as well. Q if P. We are going to see a couple of examples based on this, so that your things will get clear. Q if P. It is also equivalent with saying P conditional Q. P conditional Q means if P then Q. That is nothing other than Q if P. Q is going to happen if P is going to happen. Q is going to happen whenever P exists. Q whenever P. It is also said Q when P. Then Q follows from P. If we are having P, then Q is being followed by P. Next, Q unless negation of P, and Q provided that P. These are the variants. Okay, I have not discussed about sufficient and necessary condition yet, but do remember the common forms of P conditional Q. It will not be always in this specified format of E P comma then Q. Sometimes it may be P implies Q. Sometimes it may be making use of when. Sometimes it may use of may use whenever, follows, provided that, and so on. So we need to identify it accordingly. Now, let me take a simple example. Let's say I am saying, let P denote a sentence, P denote a preposition. Let us say, what to say, India is and Q denote a sentence. Let us say, Delhi is capital of India. In case my voice is not clear, do let me know in the chat window. Okay, if something is not clear. So how would I write this? The symbolic notation for conditional is P conditional Q. What it will be if India is, I'm writing in chart. Okay, then Delhi is capital of India. I have written in chart. So this is the basic notation that you are habitual with. You are putting comma somewhere just to make it grammatically correct. This sentence can also be written like this. The first form. Okay. What is that? I would write if India is beautiful, comma, Delhi is capital of India. This can also be written. Somebody is asking to get permission. Okay. Everything is fine. Okay. So we were discussing about this. This is the form that you know. Now, as I said, in P conditional Q, whatever comes after P is known as, what is it? It's a hypothesis. Okay. And whatever comes after then, that Q is a conclusion. That you have to remember throughout. Okay, this is hypothesis. That means it's a assumption that we are making something. Assume. Conclusion, it's a consequent. If you are clear with these terms, you would be again remembering that I have said somewhere during our last discussion. Remember, I don't know, okay, if you are remembering or not, that P Whatever is coming after if is known as sufficient condition. Hypothesis is also known as sufficient condition. And Q, whatever comes after them, what is going to happen after having some assumption or hypothesis, that is known as a necessary condition. It's a difference. Okay, sufficient means whatever is coming after if, that condition is known as sufficient condition, while whatever is coming after them, this is known as necessary condition. So if we have been given a statement, if India is beautiful, then Delhi is capital of India, what will be my sufficient condition? Sufficient condition is India is beautiful, while necessary condition is Delhi is capital of India. That's fine. So that you are observing here. What is written? P is sufficient for Q. Q is necessary for P, while P is sufficient for Q, because P will act as a sufficient condition whenever we are concluding about Q. You can also observe here a sufficient condition for Q. Q is necessary. A sufficient condition for Q is P. So what is P? P is a sufficient condition, while Q will be a necessary condition. You can observe it. A necessary condition for P which was sufficient is Q. Q is necessary for P. So these are the various variants, and I think that there were a couple of examples in your assignment number 2 as well, which were related with computing a necessary and sufficient condition, and you got confused. That was the reason why I have given that particular example, just to make you confused, just to make you ambiguous in the notion of logic. Unless and until you become confused, you are not going to search the books or ask me your doubts and difficulties. So I have observed that many students have asked me about the sufficient condition and necessary condition. I told them that once your deadline of assignment is over, I am going to discuss each and everything in depth. So that is the reason why we are taking this today. What do you mean by sufficient condition and what do you mean by necessary condition? Okay. So you can observe now. Let us take an example. Look. The normal example that is been mentioned here, if I am elected, then I will lower the taxes. This we can understand easily. Here, this could be assumed as a P, and this can be assumed as a Q. As per our understanding so far, this I am elected will be a sufficient condition for I will lower the taxes. So that means if a politician is being elected in an election, then he will complete his promises, and lowering the tax values could be one of the promises. So if this happens, this is going to happen. Otherwise, it will. Similarly, if you can check out, if you get 100% on the final, then you will get an A. It will be fictitious to say you're getting 100%. Okay, that could happen in discrete mathematics. But let us say if you're getting more than 66% in the final examination, then you are going to get a distinction. If more than 66% are scored, then and then only you will be eligible for getting a distinction. If something happens, then the other will happen. Okay, but in English, okay, many times it may or may not be related. The two or more sentences may or may not be related. For example, whatever sentence I have taken, if India is going to be beautiful, then Delhi is capital of India. Doesn't make any sense. Okay, even though India is not beautiful, then no one is restricting you to have Delhi as a capital of India. So, in the theory of logic, the given English sentences may or may not be meaningful. They may or may not make any sense. But our understanding should be restricted on learning how to represent P conditional Q, where P will act as a sufficient condition and Q will act as a necessary condition. Okay. So let me try to explain the example, solved example from the Rosen book, which says that let P denote a statement Maria learns discrete mathematics. Q denote a statement Maria will find a good job. So how to express this in P conditional Q notion? We will have, okay, If I have to use if, then I will use it if Maria learns discrete mathematics, then she will find a good job. Again, I am using she instead of Maria. So likewise, you are using in English, you can make use of appropriate statements. Okay, according. So the same sentence can also be written in alternative fashions. For example, you can say Maria will find a good job when she learns discrete mathematics. What form this is? This is Q when P. A necessary condition when sufficient condition happens to be true. So this format Q when P. So here you can observe. First of all, it is mentioned that Maria will find a good job when she learns discrete mathematics. Another thing is I can write the same statement in alternative format. For Maria to get a good job, that is Q, it is sufficient for her to learn discrete mathematics. What is the necessary condition here? Getting a job. While the sufficient condition is learning discrete mathematics. Alternative way, the other that I mentioned. Okay. Q unless negation of Q means what? Q will happen. Okay. If and only if P is going to happen. Q won't happen if P will not happen. Q unless negation of Q. Just observe the last one. Maria will find a good job unless she does not learn a discrete mathematics. Alternative means I am using here this notation Q unless negation of Q. If the sufficient condition is not satisfied, okay, then Maria won't find a good job. Okay, Maria will find a good job unless she does not learn discrete mathematics. Try to recollect the meaning of the statement. What is the meaning of statement? Maria will find a good job only if she learns discrete mathematics. Unless means if she doesn't learn discrete mathematics, then she will not find a good job. I hope the things are clear. If anything is wrong, let me know in the chat window. Can you type in chat window if it is clear to know what you mean by sufficient condition and necessary condition? How to identify the same? Can anybody type in chat window? Can you reply? Shall we move ahead? Is it fine to go ahead? Or is there any need of repeating something? I'm asking about a necessary condition and sufficient condition. Now will you be able to identify it correctly? All are present? Hello? I'm not getting any responses from your side. Yes, yes. Okay. 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 There was a delay, so I was a little bit confused. I was not getting any chat in the chat window, so I thought of what is ongoing. Yeah. 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 Okay. Okay. Fine. Now I do have again, as I said, okay. Sometimes it may be meaningful or may not be meaningful while it is written in terms of conditional statement. For example, you could observe here, if it is sunny, then we will go to beach. It is perfectly fine. It has some meaning, but in other case, it may not have a meaning. For example, if John has a smartphone, then 2 plus 3 equal to 5. Okay. How could it be meaningful? If this is going to happen, then 2 plus 3 equal to 5 is going to happen. It will not. Okay. Obviously, the having a smartphone and addition of two numbers equal to 5 doesn't make any sense, but still it is valid in the theory of logic. Sometimes statements may be meaningful, sometimes they may not have any meaning as such. Now, before moving for the next part, let me try to discuss the example which we have covered on Thursday. So I was talking Let me discuss one example out of the exercise which I have posted on your classroom so that you not have any queries as such. I think this was the exercise which was posted on your classroom and many of you were able to solve, but somebody has asked me a question related with this necessary and sufficient. Where it is? Um, I put it somewhere. Here only I guess. Where? This one. Driving over 65 miles per hour is sufficient for getting a speeding ticket. So what will be its symbolic notation? First of all, let us check what is P and what is Q. P is given as you drive over 65 miles per hour. Q is given as you get a speeding ticket. So I know that P will act as a. Let us check over here. It is mentioned that driving over 65 miles per hour is sufficient for, means this is P. This is P for getting a speeding ticket. So how would you write this? You would write this like this: P conditional Q only, nothing else. Are you getting? The answer of E will be P conditional Q. Do you have any doubt on E? Answer of E would be P conditional Q. How come? As I mentioned recently, how we are writing. Whenever you get a speeding ticket, comma, you are driving over 65 miles per hour. How to write this again? Again, it will be P conditional Q only. Alternative representations have been mentioned here of P conditional Q. On this, okay, from this only. If there is a usage of but, that means it is and. I hope examples C, D, E, F, G are clear to all of you. If it is not, you can ask me a question afterwards. Now I am having one small exercise for you. Based on this, you are going to tell me how should I do this. So I am saying there are two restaurants in Bharat. One has a sign. Go for is not cheap. Other has a sign. Cheap food is not good. Which restaurant will you prefer to visit? Question is, there are two restaurants in Baramati. One has a sign, good food is not cheap. Other has a sign, cheap food is not good. Which restaurant will you prefer to visit based on these signs? That is my question. Are you getting my question? I think the question is very simple. Okay, I will again display it here. So you have to reply in the chat box which restaurant you are going to visit out of these two. Let us say first restaurant name is A and other restaurant name is B. Whether both are trying to convey one and the same meaning, or you would prefer A over B or B over A likewise. Here we have to make use of notion of logic. Can you tell me what is the meaning of this? Good food is not cheap, cheap food is not good. Whether both the signs are trying to convey one and the same meaning, or it is something different. Both same. Neha is saying both same. What about others? Same. How come both are same? Same. Okay. Both are same. Perfectly fine. Okay, both are same. Perfectly fine. But let's try to say, let P do not. Food is good. Let Q do not. Food is cheap. So how can I write whatever is being said by A? A is saying good food is not cheap. So what is the symbolic representation of A? Good food is not cheap. Should we use conditioner? Should we use, okay, somebody is saying not same, other is saying not same. Okay, yes, is saying B. B is good, cheap food is not good. So you will visit restaurant B over A. Yes, is also saying, and Viraj is saying B. Okay, B, B. Abhishek Khamkar is also saying B. So those who were saying same, let me tell you how to check. You will be given a question in this format. If you are appearing for GATE examination or some examination which is required for higher education, then you will see a couple of questions related with this category. They will not directly ask you to construct a truth table. They will give you sentences and ask you to infer meaning out of them. So this is inferring a meaning. So let us try to denote this good food is not cheap in the form of symbolic representation. So I have taken let P denote food is good, let Q denote food is cheap, and let me try to now represent them using symbolic notation. So A was saying good food is not cheap. What should I? Good food is not cheap means I will say if food is good, then it is not cheap. That means I will say. Can I write like this? A is trying to say P conditional negation Q. Is it fine? Can we use conditional? Yes, we can use conditional. Why? Because the meaning remains same. Good food is not cheap. I am representing it alternatively. I am saying if food is good, then it is not cheap. So I have represented it using a conditional statement. Next is what? B. B is saying what? Cheap food is not good. That means if food is cheap, then it is not good. So we shall write it like this. If food is cheap, Q, then it is not good. So Q conditional negation. That's fine. And now what is the question? Which restaurant will you prefer to visit? So that means we need to check out whether both of the signs are trying to convey one and the same meaning, or some sign is having other truth values in comparison with other sign as such. That means I need to check logical equivalence of A and B. In English, we are looking out that both of the statements are trying to convey one and the same meaning. Good food is not cheap or cheap food is not good. Both makes a sense. Okay, let us try to check. So what to do? You will have a logical table. PQ, P conditional negation of Q, and you will have here negation Q, conditional negation of P. Sorry, Q conditional negation of P. We will say that both of the signs are one and the same if we are observing the truth values in both the columns exactly same. I guess we will be able to observe the same truth values in both of the tables. Okay, let us see. If something is wrong, we will be able to easily capture this. So what will be P conditional negation Q? It will be F. How F? P F F. P T T T T T. Okay. F F T F F T. This one. Now Q to negation P. So Q is true. That one is false. Next. False, false, true. True, true, true. True, true. What is this? We are getting one and the same value. That means P conditional negation Q is logically equivalent with Q conditional negation. That means both of the statements are exactly same. So your answer will be you would prefer any of these above restaurants as both of the signs are trying to convey the same meaning because of logical equivalence. Am I clear? Is it fine? Those who were saying B, whether your doubt is resolved, why not B? You could have A as well because they are having one and the same meaning using the logical equivalence. Viraj, is it clear? Yes, she's saying yes. Okay. Yes, yes. Okay. Oh, perfectly. So take one example for exercise and let me know the answer tomorrow. So I'm having that exercise in front of me. I'm not going to write it now because that is mentioned here somewhere. I'm making use of now. Where should be? So just a second. If something is not clear, do let me know. Just a moment. My suggestion is do not look for the solution on this book, okay, unless or until you solve it on your own. So what is the problem? Problem is, let me check out if I can. Okay, I have copied this so that I can show you only that part and you will not look for the solution, possible solution. So observe what is mentioned. It is mentioned an Iceland has two tribes of natives. Any native from the first tribe always tells the truth. Let us assume we are having A and B, two Icelands, and there are natives residing on those Iceland. Okay, only one Iceland, and there are two tribes, Group A, Group B. Any native from Group A or Group B, I don't know. First tribe always tells the truth, while any native from the other tribe always lies. You arrive at that particular Iceland and ask a native if there is gold on that Iceland. He answers, there is a gold on this Iceland if and only if I always tell the truth. Which tribe is he from? Is there a gold on the Iceland? That is my question. Just take it as a homework. Okay, not mandatory, but if you can solve it using the notion of logic and logical equivalence, let me know. And let me know whether there is a gold on the Iceland or not. You can take a screenshot of this example and try it as an exercise. Is it fine? Or can you tell me, sir, give one more same example which is not logically equivalent and then how to choose? Okay. Give one more same example which is not logically equivalent and then how to choose. Okay. 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 Before giving other example, uh, can you just take a snapshot of this? I will give you other example. Okay. Before going for other example, just take a snapshot that you are going to try as a homework. Have you taken? I hope you have taken. No? So I will give you other example. No problem at all. Okay. It's fine. Have you taken the snapshot? Oh. Yes. Fine. 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 So he's asking me for the other example. Okay. No problem. So let us say he is saying yes. As I mentioned, A, good food is not cheap. B is saying cheap food is not good. So first one could be represented as good food is not cheap. B conditional negation of cheap, not cheap. Okay. Second one can be represented as cheap food is good. It is mentioned cheap food is good. Q conditional P. And if you try to construct a truth table for this example, you will observe that P conditional negation Q is having truth values as mentioned over here, F, T, T, T. While if we take Q conditional P, let me take over here, Q conditional P, I would have other values. So what is Q conditional P? P, T, P. What is F, T? Again the T, PF, F, and here PF, as you observe, this P conditional negation Q, we were having F, T, 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 while in Q conditional P, we are having T, T, F, F. That means these both statements are not logically equivalent. Hence, the two restaurants, A, good food is not cheap, is saying, okay, and B is saying cheap food is good, are not logically equivalent. And in this case, which one will I prefer? I will look out at the truth values. So truth values for first, I am having three truth values in P conditional negation Q, while in Q conditional P, I am having only two true values. So the true value count in the first restaurant, good food is not cheap. It's quite good. So I will visit restaurant A in comparison with restaurant B. Are you getting? In this situation, if restaurant A is saying good food is not cheap, while B is saying cheap food is good, obviously I come to know using the logical equivalence also that A is trying to be more truthful in comparison with the B, and we will certainly not go to restaurant B. Is it fine? I have taken the same example with little bit of modification, nothing else. Is it fine? Who was having a question? Whether it's fine? One more example which is not logically equivalent, and then how to choose. So I think I have discussed how to choose. While choosing, you need to count the number of true values. So in first, you are having number of true values as 3, while in second, you are having number of true values as only 2. So 3 is more than 2. So you are going to choose first. Is it fine, Abhishek, or others? Others, do you have still?
Yes.
Yeah. Someone's mic is on. Yes. In Q column, there should be false in last place. Okay. Anuraj, where? In Q table, in Q column, there should be false in last place. So entire my values are changed, I guess. P conditional. F, T, T. Okay. In this case, Q, F2, 2, okay. Now this will be 2 to P, F, T. So, do we have any changes in other values anywhere? Do you observe anything other alternative from this? Certainly I have made the changes. So now if I compare the truth table values of P conditional, somebody's mic is on. Would you like to discuss something? Your mic is on. Rohan, I think your mic is on. You can turn it off. In this case, now if I count the true values, T, 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 I am again getting T, T, T. True values are exactly same for both P conditional negation Q as well as Q conditional P. In this case also, you will have your preference to A as opposed with B. Question would be why? Obvious question. In that case, okay, while giving a preference to A, you need to now recall the understanding and inference of English statements. So in that case, based on your inferences of English statements, if those are making a sense, you could observe if the food has to be good, then it will not be cheap. And the second one, the statement made that cheap food is good. That means food is cheap, value Q, and food is good, TT. If we are getting TT, then this could be perhaps a miserable statement which is trying to attract you based on uh, just like a China product. If we used to buy a China product, the advertise is made like if you are going to get let us say 50% discount, and there are lot many features available in the smartphone, you tend to attract that particular thing, but If we infer out of the actual product and the features, we came to know that if product is cheap, then it may or may not be good based on the specifications. On that note, we will be visiting the first restaurant which is saying good food is much. Still, if you are confused, let us try to look out at this. An Iceland has two tribes, always tells the truth while native from the other lies. The statement is there is gold on the Iceland if and only if I always tell the truth. Let P be a statement, there is gold on the Iceland. Let Q be a statement, I always tell the truth. So I will use biconditional truth table T T T. Or if first one is false, there is no gold on the Iceland, then I am not going to tell the truth. False, false, true. In either way, you could arrive at a conclusion that there is a gold on the Iceland. Okay. Let me show you one very good website that will help you to prepare more on these questions. Considering the GATE examination, as you are in the second year, okay, I don't want to create any fear in your mind about the subject, but if you are curious to know, you can visit this Geeks for Geeks logic. Okay. Discrete mathematics logic. I think we are in line with the flow of the lectures only. I am trying to give you more and more examples, as many as possible, so that your things will get more clear, and more clear. Nothing. So this is very good website to learn programming or learn any core subject of computer science and engineering. So we have not yet seen this. So let me check out the very first. Just a second. Let us directly move on towards. The examples that are in front of you. Consider the following statements. Good mobile phones are not cheap. Cheap mobile phones are not good. So it is same like whatever we were discussing recently. We were discussing with respect to restaurants, and this is respect to mobile phones. Nothing. So this website you can visit for exploring more on the examples related with these things. P is necessary and sufficient. Awesome. So my suggestion again, go to this website and try to implement something. A lot of things related with the other part we have discussed so far. Now let me start with the today's session. Okay. So something. So again, examples. First one, Mumbai, its capital of Maharashtra. 2 plus 3 is greater than 4. Third, x plus 9 is greater than 8. Fourth one, x is of 9. What do you observe? I have written a couple of examples in front of you. Our today's topic of discussion is checking out predicate. What do you mean by predicate? What are the quantifiers in the notion of logic? So one more thing, let me say x. So these are the examples that have been written in front of you. So if I ask you a question in random, okay. So out of these 1, 2, 3, 4, 5, which are the prepositions? You will say that example number 1 is a preposition. Example number 2, you will again say that this is a preposition. Okay, and for rest, example number 3, 4, 5, you are going to tell me that this is not a preposition. Alright, if in a proposition we are having some variable present for which unless and until I put a value of that variable, I will not be able to determine the truth value of a given statement. So that will not be said as a proposition. Fine. So today's point of discussion is the definition of predicate. So predicate is a statement or a preposition which contains one or more variables for which value is not known. I mean to say, you cannot determine a truth value. Can we determine a truth value for the first statement? Mumbai is capital of Maharashtra. Yes. What is the truth value? It is true. Truth value of second, 2 plus 3 is greater than 2. True. But I cannot determine the truth value for statement number 3, statement number 4 and statement number 5 because I am not sure what are the values of x or x and y in these cases. So for instance, if I put a value of x as, let us say, value of x is put as 2, I am getting a result as 2. If I put value of x here as, let us say, minus 11, then I am getting my result as false. Okay, because based on the values of x, the truth value is inferred. So if we are arriving at such notations in the logic, such notations will be known as predicates. A statement, I should say statement only, not a preposition. Okay, a statement which contains one or more variables for which value is not known is called a predicate. So if a given statement is containing only one unknown value, that sort of statement will be known as one place predicate. If you are having two or more variables, you will say that that is known as two place predicate. So in general, what do you mean by a predicate? A predicate variable is an assertion or a statement that contains one or more variables whose truth value is predicted after assigning values to its variables. Are you getting the thing? Unless and until I assign the values to the variables, I cannot determine the truthness of a certain assertion or statement. That kind of statement is known as a predicate. So this is also a predicate. X is tall and handsome unless and until I put some value of a person, individual, for X. I cannot determine whether he or she is a tall and handsome. Okay. He is tall and handsome. I cannot, because X could be a chalk. X can be a laptop. How a laptop can be tall and handsome? So we need to know the set of values beforehand, and we will put some value out of that set in place of X, and we will be able to determine the truthness. In this case also, X and Y, X greater than Y. If I put the appropriate values here, I would be able to. So how to denote these predicates? So these predicates will be denoted using capital P in bracket the variable for which value is unknown. For example, P of x is x plus 9 greater than 8. So P of x is a predicate containing x which is denoted by x plus 9 greater than 8. How to denote this? You will have again P of not only P, you may use any capital variable. P of x denote a predicate. X is tall and handsome. I am going to assume some value for x so that my statement will become either true or false. Here we are having two variables, so it will be two predicate, two plus predicate. P of x comma y denote a statement x is greater than y. Okay. Now I do have some questions related with this to you. Determine the truth value of I'm talking about example number 3. Okay, this is for example number 3. Otherwise, you would be confused again. Second, okay. Otherwise, let me make it here Q so that your things will not be disturbed, and let me make it R. So based on the assignments, we will be able to determine the truth values. So if you are having these examples in front of you, what will be the truth value of P of 1? If I put 1, P of 1 means we need to replace x by 1 wherever there is an occurrence. So you are going to put 1, 1 plus 9, 10. Whether 10 is greater than 8? Yes, it is. So truth value of example A will be true. What will be truth value of P of minus 55? Could you tell me? Any answers? F. Okay, F. F. Perfectly. You might be thinking why sir is taking so many simple examples. The reason is not everyone is having that much sort of good connectivity. Okay. P of in double quotes A. Third one C. What will be answer C? F. Who is saying F? Which of latter predicate? Unpredictable. P of A. Unpredictable. Okay. But self it is again predictable. So if we assume ASCII value of A, which is 65, capital A, 65 plus 9, 74 greater than 8. If we are assuming ASCII value for this capital A, then only your predicate will become true. Otherwise, it will be unpredictable. So it depends on the ASCII value. If it is mentioned that you have to consider the ASCII values of the alphabets, then and then only the example number C will be true. Otherwise, it will be unpredictable. It will neither be true nor it will be false, because instead of X, if you put A, it becomes a predicate with a variable A. That's right. How about fourth one? Q Virat. Virat is tall and handsome. It depends again on the one's perception. If somebody assumes that Virat is shorter than Dhoni, then it will be false. Virat is not okay tall. It depends on your perception. You could say that Virat is tall and handsome. It is true. But which Virat I am talking of matters. If I am talking of Virat as some dog or some pet who is short and okay, likewise, then this statement, this predicate would be false. If you are talking about chair, how a chair could be tall and handsome? In that case, it will be again false. Moving further, R of 5 comma 55. Just put out the value of x as 5 and y as 55. As 5 is not greater than 55, the first statement F will be false, while this case 3 is greater than 2, it will be true. Is it fine? Is it fine up to this point? Okay. Okay. Very nice. Very nice. Okay. Now, if we are having integer type of expression, okay, expression involving arithmetic operations, then the values of x will be taken from a universe of discourse that is known as domain set. I know that for this example, x plus 9, x can take any integer. So here, set of all integers act as a domain. It acts as a universe of discourse. So how can we make a predicate as true or false? We can make a given predicate as true or false by directly substituting its value. Here we have substituted 1 instead of x. Are you ready? So from where to take the values? You are going to take the values from universe of discourse. Here, what will be universe of discourse in the second example? X is tall and handsome. Can you tell me what will be universe of discourse? पहिल्या केस मध्ये universe of discourse is set of integers. What will be universe of discourse for this q of x? Can you tell me from where to take the values of x? You are going to take the values of x from names of human beings. So names of human beings will act as a universe of discourse. Obviously, you are not going to consider integer values here because integer cannot be taller and handsome. Is it fine? Am I audible? Does it make a sense? So for Q, we will have set of human beings. And for R, we are again going to have set of integers as a universe of discourse. Let me take you to this PPT. Just a second. Hold on. So up till now we have seen this. What do you mean by prepositional function? I have said prepositional function as a predicate. So instead of this prepositional function, we have meant it as a predicate. Okay. A predicate P of x is a statement involving a variable x. So P of x, 2x is an even integer where x is an element of a set D. D is called domain of P of x, or D is also known as universe of discourse for this P of x. X is an element of set of integers. I said it already. Okay. In the preposition, in the predicate, 2x is an even integer. Unless until we are aware about this domain D, we would not be able to derive the truth value of P of x. So D is the set where the x come from, which I will discuss. Okay. Now, as I mentioned earlier, very right here. So this is the one way by which we can take out the values. We are directly substituting the values for. What could be other way for determining the values of predicates? Can you tell me in the chat box the other way? First way for determining the truth value, we are using direct substitution. We are directly putting out the values. And the second way of putting the values in a predicate is known as quantification. So this is the popular term that we are going to study. So there are two quantifiers. So this for all quantifier is known as universal quantifier, and this quantifier is known as existential quantifier. So have you learned for all symbol in your mathematics? For all and there exists symbol. Have you seen that for all symbol and there exists symbol in mathematics? So that is the notion of quantifiers. Okay. So what are the quantifiers? Quantifiers are the symbols used with predicates. Forget about prepositional function. It is nothing other than predicate. Okay. Quantifiers are the symbols used with predicates. So there are two types of quantifiers. Universal quantifier represented using this notation for all. Existential quantifier represented using this notation. There exists. Example, you can observe, if n is set of all positive numbers, then the following statements are true. You can see the notation. For all x belongs to n is set of all positive integers. What is the predicate? Predicate is x plus 3 greater than 2. I can put any value of x starting from positive integers. Okay, starting from 1. So 1 plus 3, 4. Whether 4 is greater than 2? Yes. 2 plus 3, 5 greater than 2. Then 4 plus 3, 7 greater than 2, and so on and so forth. For every value of x belonging to n, my predicate x plus 3 greater than 2 is going to be true. So that is known as universal quantifier. So when to use universal quantifier? If we are observing that some predicate is true for all the values from the domain on which that predicate is defined. Otherwise, it would be a case that a predicate may not be true for all the values on which a certain function has been defined, but it would be true for some of the values. In that case, you are going to use this there exists symbol. So when to use there exists? If there exists at least one value for which given statement is true. So we can observe x plus 2 less than 7 will be true only for certain values. For example, value of x is 1, 1 plus 2, 3. 3 is less than 7, yes, true. Let us put value of x as 2, 2 plus 2, 4, whether 4 is less than 7, yes, again true. If I put value of x as 3, 3 plus 2, 5, 5 less than 7, true. X is 4, 4 plus 2, 6 less than 7, yes, again true. If I put value of x as 5, what is 5 plus 2? 7. Then 7 is not less than 7. That means there are only fewer values of x in set of positive integers and for which this predicate is true. So we can use this quantification method for putting the values in the predicate state. You can use either for all if it is true for all the values. Otherwise, you can use existential quantifier. Am I clear? Can you tell me? I'm going to revise this in tomorrow's session again, but beforehand, I have just introduced you about the concept of for all and there exists. Am I clear? Can you tell me? Yes. Okay. So I do have one example for you. You are going to tell me whether I should use for all or there exists. If it is clear, you are going to tell me should I use for all or there exists. So let me have example like this. X plus 5 greater than 55. Example A. Example B. X plus 3 equal to 5. Example C. X square greater than x. Okay, I do not have symbols over here. So this is x raised to 2 means x square greater than x. Now you are going to tell me where should I use for all, where should I use there exists. In A, B, only 3 for today. Can you tell me? For A, should I use for all or should I use there exists? Assume that we have to take the values from set of integers from A is for all. So, N is set of positive. Let me make clear. This is our universe of this course, and from this we have to take the values. Now, can you tell me? Should I use there exists or for all for A? Obviously, there exists, isn't it? Who was saying for all? Oh, it would be for all, okay? Because if you are going to put here 1 plus 5 is 6. Whether 6 is greater than 35? Obviously not. But if you are putting over here 31, what is 31 plus 5? 36 is greater than 35. Then you are putting 32, then you are putting 33 and so on. But for the values up to 30, it is not true. So there are some values for which it is false, and we want for all values in order to have for. Okay, A, B there exists. Perfectly fine. This is there exists. I'm not having that symbol. You can use that symbol. The reverse E. Okay, how to have reverse E? Here also 2 plus 3 is only 5. If we put here 1, 1 plus 3 is going to be 4. It's not true. So for this case, again we are going to have there exists. Okay. And for C, those who are saying for C for all, you are wrong. Why you are wrong? What is 1 square? 1 square is 1. Whether 1 is greater than 1? Whether 1 is greater than 1? Absolutely not. That is the reason why in C also we will have there exist. And what is my predicate? It is given greater than. It is not mentioned greater than equal to. So again, this will be there exists. And if I have other example like this, let us say x cube greater than equal to x. In this case, you are going to use for all. Is it fine? Why we have not taken here for all in C? Because there was one specific case for which 1 was not greater than 1. So there you are going to use there exists. Is it clear? No? Pallavi is saying no? Yes. So yes. Okay. Okay. That's it for today. Okay. So before I stop for today,